College Algebra Exam 1 Review. Over 1.1 through 2.8, Section 2.4. Write equation in slope-intercept form of the line perpendicular to x plus 7y minus 12 is equal to 0 and passing through 5, negative 9. Okay, so first of all, slope-intercept form is in the form of y is equal to mx plus b. And perpendicular means the slope of the first equation compared to the slope of the second equation. If you multiply those together, it gives you a -1 product, or that they're negative inverses of each other. For instance, let's say the slope of the first equation is 1/2. The slope of the second equation could be a -2, because if I multiply 1/2 by a -2, right, I get -1/1, which is simply -1. So you can see what I mean by negative reciprocal, right? Okay. So the next thing is we want to write an equation. If you write an equation, a linear equation, you would do something like y minus y1 is equal to m multiplied by x minus x1. There's an alternate way of doing that with the slope-intercept equation. If you know that and like that, you can use that way instead. But I'm going to go over using this equation right here. And we call this one, so this right here is the slope-intercept one, the one that's y is equal to mx plus b, and we call this one the point slope equation, because literally you can plug a point in here where it says x1 and y1, and you can plug in the slope where it has m. Okay, so to use this equation, we need a point, which is great, because say this one right here is 0.1, then that would give you x1 and y1, right? And why the one subscript? Well, because it's 0.1. Now you notice we don't have a slope. Well, we need to find a slope. Okay, now how can we find a slope? Well, you can actually use the slope-intercept form of the equation, solve, right, for y, and the coefficient in front of your x will be your slope. So for instance, this equation right here, x plus 7y minus 12 equals 0, if we solve for y, the coefficient in front of the x is going to be the slope. Okay, so for instance, we could say minus x, cancel, cancel, and that would give you 7y minus 12 equals negative x, and then you'd say plus 12, cancel, cancel. You would say 7y is equal to negative x plus 12, sorry. Then you'd say undo the multiplication of y by 7 by dividing by 7, by dividing by 7, by dividing by 7, cancel, cancel, and that would give you y is equal to -1/7 x plus 12 over 7. Okay, and this number right there in front of the x, the coefficient of the x, now that I've solved for y, is going to be m. So m is equal to -1/7. Okay, so that's I'm just going to differentiate this. Now they don't want us to use that slope; they wanted it to be perpendicular. And if you remember, perpendicular is the negative reciprocal, right? So if m1 is equal to -1/2, then m2, the one that we're interested in, it has to be equal to a positive 7/1, which is just 7. Okay, so now we got our slope. We have our slope, we have a point, we have the information necessary to plug it into this equation right here. So what's y1? y1 is equal to a -9. What's m? m is equal to a positive 7. What's x1? x1 is equal to a 5. Okay, now we simplify. Minus a -9 is equal to y plus 9. We keep the 7, x minus 5. We distribute within the parentheses, so we have y plus 9 is equal to 7 times x, or 7x, and 7 times -5, which is -35. Okay, we finished solving for y because they did want it in slope-intercept form, so I say -9, cancel, cancel, and y is equal to 7x, and -35 minus 9 is -44. Okay, and because we solved for y, it looks like it is in fact in slope-intercept form. Okay. So use transformations to graph f of x is equal to x squared to graph the following function: g of x is equal to -2 multiplied by parentheses x plus 2 in parentheses to the second power plus 1. Okay, so first let me differentiate these two. So we know that the parent function of this Hopefully you can see the blue there. Okay. I'm making the points larger than probably necessary just to kind of so you can see it better. And I'm just filling them in, all the points. Okay. Yeah, there you go. Okay, cool. So this is a parent function. This is not the function we're graphing. This is the base function or parent function. All right, so this would just be x squared. Okay, so that's what I'm just graphing there. Okay. Now, let's use the new information from this. Now, based upon the fact that it has a negative, we know that negative right there means it's going to face down, not up. We know because the absolute value of a -2 is greater than, right? Greater than 1. So it's greater than 1. It's going to be stretched. Tall, thin. Okay. Right there. And that's where I got that information right there, that -2. Because of this right here, that +2 there, that means it's going to be shifted to the right. Now it has the opposite effect whenever you have it inside of the parentheses, like right that. So you might think +2 would be 2 to the right, but it's the opposite. So it's actually going to be 2 to the left. Okay, and because of this, there we have it in. This is going to be shifted vertically, right? Okay, shifted to I'll just put up there, right? So again, this is vertical shift over here, and this is horizontal shift over there. Right? Okay, so that's all the pieces that we have to deal with. So first, let's move let's move this origin, right where the vertex is, right there in the middle of the origin. And what we're going to do is we are going to move it according to this. We're going to shift it 2 to the left and then up 1. So to the left, up 1, which means we shifted right there. Once I draw the new vertex here, because it is facing down, right, and I am doubling, well, unless you know what it looks like, it's not a bad idea to make a table like this and plug everything in, right? So we could start at the vertex that we moved over there. It went from 0, 0. It went 2 to the left and then up 1, and that point right there is going to be a -2, +1, right? Now we're going to fill it in on each side. Okay, so what happens if I go 1 to the right? Well, then it's a -1. So I'm going to plug in a -1. What happens if I go 1 to the left of -2? I get a -3. Then I go 1 more. It's going to be a 0 towards the right. And I go more to the other one, -4, right? So just kind of fill it in, right? So what do I do? There are several ways of doing this. One is just brute force approach, is you just plug it in, right? So you do, g of -1 is equal to -2 times -1. Oh, sorry. Plus 2 squared plus 1. And that would give you g of -1 is equal to -2. And -1 plus 2 would give you a +1 squared plus 1. And then 1 squared is going to give you a 1. 2 times 1 is going to give you a 2. And it's a -2 times 1, so it's a -2 plus 1. And then sure enough, we have a -2 plus 1, which gives me a -1. So that'd be -1, -1. Okay? So from there, -1, -1 would be right there. Okay? And that means it's symmetric, so there's going to be another one over there. If I plug it in, that's what I'll get. And you can plug in all these points, right? So that I plugged in the -1 right there. But you can also plug in the -3, the 0, the -4, and you're just trying to fill in the graph, right? So I started right there in the graph, and I'm filling it in, right? Now, if you kind of understand what all the stuff we wrote as far as how we're stretching it and everything, you can actually finish this off, right? So it used to be, for instance, originally it was 1 up and 1 to the right, or 1 up and 1 to the left. Now it's 1 to the right and 2 up, or in this case down, and then it's down over to the left 1 and then 2 down. So you just double the differences on the y-axis, right? So right here it was 2 to the right, originally, and then it was 4 up. Well, now it's going to be 2 to the right. It's not going to be 4. It's going to be 8, right? So down 1, 2, 3, 4, 5, 6, 7, 8. And you would draw the point right about there. And since it's symmetric, you'd also go over here and you draw another point. And we can just verify that, right? So let's verify it. So let's see. I'll even do -4 just to verify what happened. So we see -2 times -4 plus 2 squared plus 1. And that would give me -2. -4 plus 2 is -2 squared plus 1. And then what we would have is a -2 squared, which gives you a 4. Because -2 times -2 is 4. Whoops. So that's a 4 plus 1. You say -2 times 4 is -8 plus 1. -8 plus 1 is -7. Which should be right here. And let's see what happened. Sure enough, we ended up with -4, 7, which is right there. So that actually worked, right? And then mirror image across the vertex, sure enough, there's another point over there. So if we plug in a 0, we would expect the same kind of thing. And yeah, it verified. Yeah. Okay. So we know we're right. We could predict it either with just looking at the transformations based upon the stretching and the horizontal and vertical transformations, or you could actually plug it into a chart like this, and you could figure all of them out, right? Find the domain of the function, write in interval notation, do not use imaginary numbers. Okay, now, there is a limitation on the domain here because you have variables in the denominator. What we do not want is we don't know the denominator equal to 0 because that would make it undefined, right? Undefined. Okay, and we don't want that. So what we do is the denominator cannot be equal to 0. So if we set it equal to 0 and we solve it, that will tell us what it cannot be equal to. Okay, so what we can do is we can solve this. This is it's a simple trinomial, meaning it has a 1 leading coefficient. So the square root of x squared is a 1. I put it in first place of both of those. One of them is going to be addition, one is going to be subtraction, and one is going to be a 4, and the other is going to be 4. Okay, so we're using the zero factor property. First step, set it equal to 0. Second step, factor. Third step, set the factors equal to 0. So -4, -4. X is equal to -4. X -4 equal to 0, plus 4, cancel, cancel. X is equal to 4. Okay, so what this really means is X can not be equal to a -4 or a 4, right? If we were using kind of a set notation, it would look like this, with the, X such that X is not equal to a -4 or a 4. But they ask for interval form. Now you can graph this first. If you find that useful, you can graph this first. So for instance, I'll put a little 0 there, I'll plot my -4 over here, I'll plot my 4 over here, and we'll just graph out what it says, right? So it says X is, again, this is not equal. It's not equal to that. So it can be anything but that. So essentially, I mean, if you use a kind of an alternate form of notation, if you put like an empty circle here, right? We're not going to do that because we're going to be using the parentheses. But the point being is that we go around here, around there, around there, and around there. And then everything else would be kind of shaded in, right? Everything but the -4 and the 4. Now we want to include everything else but the -4 and the 4 in the interval notation. Now over here to the left is a negative infinity. So if I were to write that part, it would be negative infinity all the way to -4, but not including -4, right? Over here to the right is a positive infinity, right? So if I was to write that part right over there, that would start at +4, go to positive infinity, right? But it wouldn't include 4. And then there's also a part in the middle, right? This part in the middle right here, around 0. Well, it starts at -4. Let me give myself a little more room than that. Okay. So that part right there starts at -4, but not including -4. And then it goes to +4, not including +4. And how do we put all these three pieces together? We use the union symbol, right? So we say it's negative infinity to -4, union -4 to +4, union 4 to +4. And you can see that there's simply holes, right? So it matches the graph. There's simply holes at where the 4s are, right? There's holes around the -4 and there are holes around the +4. So this whole thing right here is the interval notation, right? It's the interval notation.